Hi everyone, if you weren't here on Monday, we did a lesson on surds, and that is also going to be our goal today. So Monday's lesson and today's lesson are on simplifying surds. So what is a surd? To understand a surd, we first need to understand rational numbers. Okay, and rational numbers are those that can be expressed as a fraction a on b, where a and b are integers. So let's consider some examples of that. Okay, any two numbers a on b that are integers, such as numbers like -5 on 3, 2 on 7, even if we consider the number 10, that is a rational number because that's just 10 on 1. We also have our favourite irrational number from Junior. Can you think of it? No, it's pi. So pi cannot be represented as an integer divided by another integer, which is why it is irrational. Surds are irrational numbers, a special different type, and where they're expressed as an integer under a root sign. For example, root 3 is a surd because it cannot be expressed as a on b. Conversely, root 25 is equal to 5. Okay, so because we can actually evaluate that, that means that root 25 is not a surd. Okay, root 25 is equal to 5, so it is a rational number. All right, let's get started on some surd rules for simplifying. So these rules here in red are going to make our life a lot easier to do these examples down the bottom. Okay, so here we've got our product rule, our quotient rule, and our rule up here that says the root of x all squared is equal to x. So first of all, if we have the product of xy, that's the product of root x times root y. If we have x divided by y square rooted, that's the same as root x on root y. And as I just said, if we have the square root of x squared, that's equal to x. So let's get started. If I think of root 32, okay, I'm going to try and simplify that as much as possible with my surd rules. I need to think of a square number that is a factor of 32. A reminder of square numbers, that's these guys that I'm going to write over here on the right. 1 is a squared number, 4 is a square number, then we have 9 as a square number, 16, 25, 36, and so on. They're our square numbers. So heading back to our example, let's think of a square number that's a factor of 32, and we can think of 16. So 16 times 2 is 32. We can then use our first surd rule to break that up. So that's equal to root 16 root 2. And now we have root 16. That's not a surd, that's just a number. So let's highlight that guy and we can evaluate root 16. Root 16 is just equal to 4. So 4 root 2 is the answer we're after. Pause this video now and have a go at simplifying these other 3 examples. All right, so as I said before, step 1 is we want to look for a square number that is a factor. So if I think of 3 root 200, I think of 100 times 2. I'm going to use that first rule again to separate that to root 3, root 100, root 2. I can see there that root 100 can be evaluated. So that's just going to be 3 times 10 times root 2. Which gives us 30 root 2 as our answer. Heading over to the next example now, I want to think of a square number that is a factor of 40, and all I can think of is 4. So let's write that as 4 times 10, keeping our denominator of 6 there. Separating that out again, guys, so we have 5 root 4 root 10 over 6. That root 4 is just sitting there asking to be evaluated. So we're going to do that. We've got 5 times 2 root 10 over 6. Awesome. Let's simplify now while we can. So we can cancel that out just as so, which gives us a final answer of 5 root 10 on 3. Our final example over here, we've got the square root of 75 on 9. The cool thing about that is that 9 is already a squared number, which is super awesome. So we just need to think about a square factor of 75. Using the second surd rule, we're going to break that into root 25 times 3 all over root 9 in the same step. So using that first surd rule, we write that as root 25 root 3, and I'm going to divide that by 3. So I'm going to evaluate that root 9 on the denominator there. In the next step, I can see that root 25 hiding there, and I'm going to evaluate that as well because that is rational. That will give us 5 root 3 on 3. Awesome. Now, the next thing we're going to be asked to do is actually do the opposite of this. So, for example, I can be given already simplified surds, and I might be asked to write these as a single surd or a surd that only has one integer underneath and no numbers at the outside. So let's consider 2. I need to think of how to write 2 as a surd. So the easiest way to do that is to square 2. So 2 squared is 4. So another way to write the number 2 is as the square root of 4. Multiply that by the square root of 5. Okay, using that first surd rule in reverse now, we can write that as the square root of 4 times 5, which is just root 20. Have a go now at the second example. Okay. So we need to think about 7 here. So how can I write 7 as a surd? Well, I need to square it again, right? So rather than writing 7, I'm going to write root 49. We multiply that by root 2. Then we're going to use that surd rule in reverse. That's the square root of 49 times 2, which gives us root 98. Awesome. So guys, in terms of practicing this stuff here, the chapter is very repetitive. So if you head to 3A, questions 4 to question 7, I just want you to do 3 of each of those questions. Okay, so there's about 9 or 15 of each. So just pick 3 of each of those types of simplifying surds. If you want a bit more of a challenge, head down to question 8 in the book for some problem solving and pick 3 out of the 6 questions in question 11 as well. Thanks everyone. Happy surds.